So today's example during the tutorial, this is basically the graphical view of it. We spoke of a variable as a container in memory. So usually when interacting with a program, you store items in memory, and a variable was said to be a container in memory. So if we can look at the statements on the left, we have a to be equal to 5, which means that in memory there's a container called a, and that container is having the value 5. We have another container being assigned the value 2. What we are doing is we are giving a container in memory a value 2, as we can see on the right hand side. Now there's this particular thing that we are doing is what we call an assignment, just like we've talked about already. If we proceed, then saying that we want to assign the container C the expression a plus b, what this one actually means is we have a container in memory called C, or we want to create a container in memory called C, and what that container is storing is the value after we have added the contents of the variable a and then variable b. Variable a and variable b have values, so it is the values that we are adding on the right hand side. So we are adding the values 5 and then 2. The answer that we get is what we assign to the container C. So basically on the right hand side, we can see that we now have a container C, and that container C is having the value 7 because we added the contents of A and B and then we gave it to the variable C. Okay, so basically that is what we did. Now there are instances where we will want to increase the value of a variable. So in memory is what sort of represented on the right hand side. So over here we have a variable a, and then the value of the variable, as I've always been saying, the variable is a container. The value of the variable is 5. So the moment we say that, now we have another statement after the initialization. The moment we say assign the value of a plus 1 to a, what we are doing is a already has a value, so we are adding 1 to the value of a, and then the new value that we get, we are assigning it back to a. So a now gets an increment. So basically we have 5 over here, and what we are doing is the value 5, we are taking the value of a, which is 5, we are adding 1 to it, and then the value we get, we are giving it back to a. So that is what is demonstrated on the right hand side. You can see we have two containers now. We have just the a having a value of 5. What we are doing in the next statement is we are increasing the value of a by 1. So saying a plus 1, what we are doing is we are getting a new value of a, as we can see from the mouse pointer. We are getting a new value of a, and that value of a is 6. So that 6 now becomes the new value of a over here on this side. Okay, you can follow the mouse pointer, you will sort of get what we did in class like right now. I mean the tutorial session. Okay, so now we are going to talk about relational expressions. We have a variable called x, and the x is now equal to 1. Now let's ask ourselves, is the value of x less than 10? If the value of x is less than 10, these expressions labeled a, b, c, and d will give us a Boolean value. In relational expressions, the answer for every relational expression is a Boolean value. What they are saying is they've compared and they are claiming that this is a statement. Is the statement true or false? So having x, and they are saying that x is less than 10. Is it true that 1 is less than 10? If that is the case, then the answer is actually the answer after evaluating the particular statement on the screen. So for A, we have x to be 1. Is x less than 10? As we can see, the value of x has been the variable x has been assigned the value 1, and we are comparing to see whether the x variable is less than 10. If that is the case, then the expression a, the expression I've labeled a, is true. If x is less than or equal to 10, the moment you see less than or equal to, they are talking about two things and only one will be true. Is x less than or is x equal to 10? X, as we can see, which is 1 over here, is less than 10. So since x is less than 10, then it means that at least that particular statement satisfies, is satisfied, and then now that particular condition is satisfied, and then now the statement B is also true. All right. Now we go to statement C, which says that, okay, I think statements C and B are the same. The next one says that x is greater than or equal to 10. X is neither equal to 10, x is neither greater than 10. So the D is false. The E says that x is not equal to 10. This is another way of writing not equal to in some cases. And I think the F is also, x is not equal to 10. It is true that the 1 is not equal to 10. So basically, that is it. Let's proceed to the next slide and see what we have. Now on the next slide, we have an update. When I say an update, we are changing the value of x. So x is 1. What we are doing on this right hand side is we are saying that the value of x, which is 1, add 9 to that value 1, and then assign the value to x. So now x becomes 10. So we add the value of, as we said, that program executes a statement from left to right on the same line. This is on the same line. At least I'm trying to create an illustration. So you have x, and then what we are doing is the moment you meet the assignment operator, you do what's on the right hand side. When you are done, you assign it to the value on the left. And so we have 1 plus 9, and 10 now becomes the new value of x. Let's take a look at these things over here as we did in the previous slide. A, which is saying that x is less than 10. X is less than 10. Okay, now looking over here, we have 10, and then you are saying that 10 is less than 10. Is it true that 10 is less than 10? 10 is not less than 10, so A is false. A. The mouse pointer is missing. Now we go to B. X is less than or equal to 10. X is actually 10, but is it less than 10? No. Is it equal to 10? Good. It's equal to 10. So at least it matches one of the conditions. So the B is right. That statement is true. When you go to the C, I think it's the same as the B, so we skip that. X is greater than or equal to 10. X is 10. X is not greater than 10, but x is equal to 10. So basically, the two things that they are checking, one is right. So x is actually greater than, x is actually equal to 10. So for that, we say that D is correct. We go to the last one, which is saying that x is not equal to 10. The last one is actually the same as the E, so we should sort of understand that. And that's saying x is not equal to 10. But we increase x from over here. Should have brought this particular expression down here so that at least we get the concept. But basically, we are on the same line, so I guess that particular clause is met, where we now execute from left to right, top to bottom. So let's proceed to a loop. So I'm sort of describing a loop using this pictorial form. I used Microsoft, the PowerPoint, PowerPoint to sort of create this kind of analogy. A loop will continuously run whatever is inside it, except that condition that it checks is false. Right now, the condition on the screen is true, so the loop is continuously going to run. The moment the condition changes to false, the loop will run no more. So let's see how the whole thing goes. So it runs round, goes again, to go again. Yes, goes again, and now it changes to false. Oh, it doesn't run again. So that's basically the concept of a loop. Let's see it in another form. Now, this is actually a loop to print the first 4 counting numbers. And as the animation is running, I'm going to explain something. I'll reverse it back and then explain the stuff again. Before I now press play, let's take a look at it very carefully. We looked at this example in class, and the example in class was supposed to print the first 10 counting numbers. This one, because I'm trying to create an analogy, I simplified it back to first 4 counting numbers. Right now, with the initialization, what happens is we get a variable in memory, just like we did in the first slide, and then we assign that variable the first of the counting numbers. Okay, this is more or less, you can do it in a lot of ways, but it's more or less a way that will help you, because if you are supposed to do something for counting numbers or something about counting numbers in the loop, then the moment you initialize the variable, and that variable is actually the first of counting numbers, your condition should allow that variable to enter the loop. In that case, we need to set the first of counting numbers to a particular variable, which I chose I. And as a result, I have my condition in the yellow box over here. If you follow the mouse, you will get me. Now, what we do now is a loop runs, let's say, in circles, and you can think of any part of the circle as having a statement. Now, over here, I left all these parts and I brought my statements to source of the end. So what this my loop does is, just like for every loop, we have the initialization, we have the condition, and then we have the update of the variable. We get an update for the control variable so that the loop does not run forever. In the previous slide, we saw that when the condition was true, the actions were repeatedly executed until it runs to false. So what we are doing over here is a loop. In the sense of programming, what happens is there is a condition, and usually there is a control variable. So you can think of this as a while loop, where the while loop now has a variable that controls it, which is the loop is going to run while the value of I that you are going to use is always going to be less than or equal to 4. So if I is 4 initially, then if I is going to be compared with this 4, if I is 1 initially and I is going to be compared with this 4, then they are going to say, hey, this part is true, because we've already done that in the slides before here. So if I is true, then do whatever you want to do in the loop. And as you can see, as I told you, you can imagine or you can think of any part of the circle as having an action. So the first action says that display I. The next action says that assign one more, increase the value of I, and that becomes the new value of I. The moment it becomes the new value of I, I has changed now. So they compare a new value of I to, they compare it to 4 in this condition. If the condition is true, they will now execute by displaying I. After displaying I, they will increase the value of I again. So let's watch the slide once more. So now I is 1 because we started a loop with 1. It runs and then it displays 1. The moment it displays 1, it increases the value of I, getting us 2. 2 goes in there and then 2 is displayed. Now what it does again is 2 is incremented, we get 3. And then the process continues until 4 is incremented, we get 5. And 5 is not less than or equal to 4. So it is dropped. That is where we end the loop. Okay, so the moment you use a control variable, that control variable should have a point where it stops, or it makes the loop false. It makes the condition of the loop false. The moment that particular thing is satisfied, trust me, your loop will end. And then because we are using a sequence control structure in programming, it will go and then continue with the rest of the statement that follow the while loop. So basically, this is a visual to sort of demonstrate what we have been talking about, and then this is the end of the session. We've not done decision making, or so maybe later. Okay, bye.